Hello students, we are starting a new chapter today which is number 10th, magnetic fields due to electric current. This is a chapter which is more or less related to magnetic effect of electric current, and some basic part we have already studied in your previous standard. Okay, so just let's go through the introduction of this chapter. Electrostatics, you know that we were studying forces on charges which were at rest, correct? Whereas in this chapter, you are going to study about the forces acting on charges which are in motion. Because we know electric current आया मतलब क्या? The electrons are moving. Okay, so जब electrons move होते हैं तभी हम current बोलते हैं. तो जब electrons motion में है तभी उसके ऊपर जो भी forces act होगा, those all things we will be studying under this chapter. We will be studying a very interesting concept called as cyclotron. Okay, ये transformer movie जैसा term लगता है, megatron and all such things. Okay, then we will be studying some new laws related to some scientists like Bayard, Severt, Ampere. Okay, ये सब laws सीखना है. As of now, let's move on to the introduction part about this chapter, which is related to the scientist named Hans Oster. You must have heard of this scientist. What did he say? He was the first person to find out the phenomenon of magnetic effect of electric current. Okay, इसका तो idea तो होगा ही. What he did, he took a wire, connected it to a cell or a battery, and near the wire he kept a magnetic needle like this. Okay, so what was his observation? As soon as he inserted the key over here, जैसे ही उसने करंट स्टार्ट किया, करंट विल फ्लो फ्रॉम पॉजिटिव टर्मिनल टुवर्ड्स नेगेटिव टर्मिनल. जैसे ही की इंसर्ट किया, करंट स्टार्ट किया, he observed that this magnetic needle got deflected. घूम गया magnetic needle, correct? So he thought कि ये ऐसा क्यों हुआ, why it happened. So he tried to find out the answer for this, and he came to the conclusion कि वायर के अराउंड भी एक मैग्नेटिक फील्ड क्रिएट होता है. Okay, so let's say here there is some magnetic field created around the wire. So अगर इधर magnetic field create हुआ है तो इधर भी north pole south pole generate होगा, correct or not? So north सामने नहीं रह सकता, या तो फिर south सामने नहीं रह सकता, और इधर north सामने नहीं रह सकता, या तो ये south और ये south सामने नहीं रह सकता. And because of that it will try to run away. What will try to run away? Magnetic needle. Okay, so दूर जाएगा, and hence there was some deflection. So through this concept, through this experiment, he understood that around a wire which is carrying a current, always magnetic field is generated. Hence the topic name is magnetic field due to electric current. Got this? Now we have to understand one very important rule, which is right hand rule. I would say right hand thumb rule. ओके, वेरी इजी टू अंडरस्टैंड. इसमें आपको इमेजिन करना है कि आपके हाथ में एक वायर है जो करंट कैरी कर रहा है. इमेजिन करना है, एक्चुअली होल्ड नहीं करना है. ओके, सो इमेजिन यू आर होल्डिंग अ वायर कैरिंग करंट इन योर राइट हैंड. ओके, एंड थंब का डायरेक्शन होना चाहिए करंट के डायरेक्शन. ओके, सो कर्ल्ड फिंगर्स जो रहेगा दैट विल गिव यू द डायरेक्शन ऑफ मैग्नेटिक फील्ड. Okay, so in this case also this is your wire which is carrying current. तो इसको imagine करो ऐसे hold किया है हाथ में, current देखो right side में है. So this is the perfect way to hold this. So this is how the magnetic field is present in the form of circles. इधर अगर आ जाओ तो ऐसे hold करेंगे. Okay, current is in downward direction. So here the magnetic field is in form of such type of circles. So this is what is your right hand thumb rule. There's one more rule which is called as right hand rule. Sometimes we link this with Fleming's rule also. Okay, with some changes. ये 10th standard से थोड़ा अलग है. Let me tell you, if you are studying the concept of electric motor, 10th standard में आपने Fleming's left hand rule use किया था. Same concept you can apply with the help of right hand rule. Okay, thoda changes hai. I'll tell you what are those changes, but answer you will get the same. What do I mean by the answer? Like directions you will get the same, whether you apply Fleming's left hand rule in electric motor or whether you apply right hand rule in electric motor, the directions will be given same. So right hand rule kisse related hai? We require direction of current. Second, we require direction of magnetic field, and then we get the direction of force. Okay, so ये तो एकदम simple concept है. Okay, so current is denoted by your first finger, magnetic field by your second finger, and force by your thumb. Okay, so let's try to understand. First finger, okay, this is your current. Second finger, this is your magnetic field, and thumb, this is your force. Correct. So this would be the perfect position. This position should be such that you can see this as perpendicular. See this one also as perpendicular. All three should be perpendicular to each other. Okay. So I repeat: current, magnetic field, and then this one will be your force. Let's apply in a straight wire. Let's say I have a straight wire over here which is carrying current in upward direction. तो force का direction किधर होगा as well as magnetic field का direction किधर होगा. So first finger I will keep it in upward direction. मेरा thumb देखो किधर आ रहा है. It is coming left side, and मेरा second finger it is going into the board. So I will be showing direction of force this side. ये हुआ फोर्स का डायरेक्शन, एंड ऐसा अंदर की तरफ समझो ये इनसाइड वी कंसीडर द डायरेक्शन ऑफ मैग्नेटिक फील्ड, एंड दिस इज नथिंग बट आवर करंट. आई होप यू अंडरस्टूड हाउ टू अप्लाई राइट हैंड रूल. गॉट दिस? So this was just a brief introduction about this chapter which you might have already studied in your previous standards. Okay, students, let's move on to the next topic, which is magnetic force. We have studied that direction of force can be found out by right hand rule. Okay, now let's understand the formula of this. So from the direction, what you understand is the current and magnetic induction. I hope you know what is magnetic induction. Magnetic induction is nothing but the strength of magnetic field at a point. Very important term, please don't forget it. Magnetic induction, which is denoted by letter capital B. I'll write this. It is strength of magnetic field at a point. So in short, magnetic field का एक value बताता है. Magnetic induction gives you the magnitude of magnetic field present at that point. Similarly, analogously, we have a term called as electric field intensity. It is denoted by capital letter E. Okay. On similar lines, as I told you, it is analogous. So इसका definition ऐसे ही लिख सकते हो, strength of electric field at a point. Got this? Now the important part over here is we are going to study magnetic force, and in that magnetic force, capital E as well as capital B, both terms are going to come. Okay, so velocity of an electron, let's say a charge which is moving with some velocity. Okay, in a magnetic field. So यहाँ पर charge आया मतलब Q आ गया, correct or not? It is moving with some velocity, so V आ गया. What's this? And then it is in a magnetic field, that is B. So it will be acted upon by some force. So वही force का formula है F is equal to Q V cross V. In vector form I will be writing Q V cross V. Now why V cross V? Because we have already studied that force is perpendicular to both of this. Correct or not? So cross product याद करो. Okay? Vector product, scalars, vectors का topic. Cross product रहता है. So if one vector is this way, another vector is this way, then third vector will be perpendicular to both these vectors. Understood? Hence the cross product will come. Clear? Now, if I remove this cross product, then I can write F is equal to QVB sin theta, because cross product में sin theta है and dot product में cos theta है. Got this? Now let's move your focus to electrostatics. Electrostatics में electric field intensity का एक formula है. Like I'll give you an example. समझ लो इधर एक charge है, huge positive charge. इधर एक छोटा सा टेस्ट पॉजिटिव चार्ज है, तो ऑब्वियसली इन दोनों का रिपल्शन होगा. तो इसके ऊपर एक फोर्स एक्ट करेगा F. गॉट दिस? ये चार्ज को हमने Q नॉट दे दिया फॉर एग्जांपल, टेस्ट चार्ज. तो हमको क्या मिलेगा? इधर का इलेक्ट्रिक फील्ड इंटेंसिटी मिलता है. सो इलेक्ट्रिक फील्ड इंटेंसिटी फॉर्मूला वाज F अपॉन Q नॉट, इफ यू रिमेंबर इलेक्ट्रोस्टैटिक्स. सो देयरफॉर F का फॉर्मूला क्या हो जाता है? F इज इक्वल टू Q not into E. So in short, force due to electric field can be given by charge into electric field intensity. Got this? So now when we consider a force which is due to electric field intensity as well as due to magnetic field intensity, then we will have to write a new term which will be F L. I'll tell you what is L. Will be equal to Fe plus Fm. Fe is nothing but force due to electric field. So उसका फॉर्मूला हमारे सामने है. क्या लिखना है? QE. Okay, I'm not considering test charge. I'm considering this same charge Q. And force due to magnetic field क्या फॉर्मूला रहेगा? QV cross B. This is also vector. So this is how we get the total force acting due to electric field intensity as well as magnetic field intensity. And this is what we will be calling as Lorentz force, Fn. So I told you, L क्या है? L is nothing but Lorentz force. Got this? So students, using that formula of F is equal to QVB, we will try to understand magnetic induction in bit detail. Okay, this I can write as F is equal to QVB sin theta. Theta we will consider as 90 degree, means these two are perpendicular, angle is between V and B. So therefore we will be writing it as F is equal to Q V cross V into B. Sin 90 is 1. Now from this, what you can understand, capital B will have a formula F upon Q. Correct or not? Capital B will have a formula F upon Q. Correct? Now we will try to find out the units. See, force unit will be Newton, charge unit will be Coulomb, velocity unit will be meter per second. So that is how we finally get Newton second per Coulomb meter. This whole term is given a simplified name which is Tesla. Okay, I'll write this Tesla. This is the unit of magnetic induction. I think you must have seen this already in your 11th standard. It's not a new term for you, not a new unit for you. I'll just give you one more unit simplified unit, commonly used unit, which is called as Gauss. This term is also not new for you. Gauss law, you must have already studied it. So there is a relation between Tesla and Gauss. 1 Tesla becomes equal to 10 raised to 4 Gauss. Understood this? Now, using this relation, we are going to find forces direction in different cases where you have been given direction of velocity, you have been given direction of magnetic induction. So let's have some cases where we are going to find the direction of forces. So students, let's start with the finding of direction of force in various cases. So I'll be telling you two methods. First, we will be applying right hand rule. I told you about this. Okay, as well as we will be applying the cross product rule. Okay. First, let's take this case. You can see there are three axes, x, y, z, and directions are already shown. That velocity is in negative x-axis, magnetic induction is in negative y-axis. Let's try to find out the direction of force. First, I'll be applying this one. So you know that first finger should be in the direction of velocity, that is the current. Okay. Then the magnetic induction should be shown by second finger. I hope this is very well fitting in this case. And my thumb, if you see, it is coming outside. I hope you can see that. Thumb is coming outside. So force का direction बाहर की तरफ है, outwards. Understood? Now same thing, let's try to find out with the help of this concept. अब ये concept में करना क्या रहता है? First vector जहां पर भी है, वो direction में अपना palm रखो. Like V, I'll be keeping in the direction of V, the palm, correct? And then bend the fingers in the direction of other vector. Okay, इसलिए इसमें sequence बहुत important है. Understood? So I'll keep like this and then I'll bend this way. B की तरफ मैंने bend कर दिया. Understood or not? So this is how the force is again coming outward. So in both the cases, the force is outward. So force outward, let's say this is that part. This is the direction of force. समझ में आया? Let's move on to the next part. In this case, you can observe that V is in downward direction. So obviously my first finger should be acting in downward direction. What about B? B is actually inward. अगर ये outward है, तो ये inward है. So अभी मुझे क्या करना पड़ेगा? This way I can show, and my second finger should be going inside. So I hope my hand is getting twisted a lot, but I am managing this way. My second finger is going inside, and my velocity is coming downward. So you can see the force which is going on this side. Okay, I'm not able to twist that much, but I hope you can understand. Okay, so this is how you will get the direction of force on the right hand side. So इसी में second method बहुत helpful होगा, because if your hand is getting twisted a lot, ये method use करो, easily answer मिल सकता है. Got this? Now what I'll do, I have to show my hand in the downward direction, correct? This way, in the velocity direction. B is going into the board. So when I show my hand downward in velocity direction, मुझे अपने fingers B के side bend करना, correct or not? So B is going into the board. So ऐसा अंदर की तरफ मैं bend करता. So again you can see the force is going to come onto the X direction only. I hope you got this. Okay. So this is how you can get an idea about the bending of force. Okay, direction of force. I'll show it again. This is your B. Okay, sorry, this is your velocity, and then you bend it like this. So again, your thumb is again pointing this side. That is the direction of the force. Got this? Let's move on to the third case. In this case, you can observe that velocity is in this direction, magnetic induction is in this direction. There is no way that you can show your two fingers opposite to each other. ये तो 90 डिग्री बन सकता है, correct or not? So इसको तो opposite दिखाना possible ही नहीं. So in this case force किधर है? Where is the direction of the force? You can try it n number of times, but आपका ये दो finger opposite direction में नहीं होगा. Never possible. Don't think like गोलमाल, like Ajay Devgan is bending your fingers in opposite direction. ऐसा कुछ होने वाला तो है नहीं, correct? So इधर क्या करें? Here the concept is F is equal to Q V cross B. अब आपको करना क्या है? V B sin theta. Okay, so here actually the angle between this is equal to 180 degree. So यहाँ पर आप 180 put करोगे. So sin 180, you know it is equal to 0. Okay, so this whole term will come as 0. Therefore force value is going to be 0 in this case. So force है ही नहीं तो डायरेक्शन निकालने की जरूरत नहीं है. Understood? So this is that simpler case. Let's move on to the last case. In this I have shown circle and a dot inside that. इसका मतलब क्या है? B का डायरेक्शन आउटवर्ड है. Okay, B is coming out of the board. अगर मैंने ऐसा दिखाया है सर्कल के अंदर क्रॉस, ओके, कंप्लीट क्रॉस लाइक दिस. अगर मैंने ऐसा दिखाया है मतलब बी का डायरेक्शन इनटू द बोर्ड है, अंदर की तरफ, और ये आउट ऑफ द बोर्ड है. दिस इज अ कॉइल, रेक्टेंगुलर कॉइल है, ओके, जिसमें करंट का डायरेक्शन इजीली शो किया है मैंने. आई होप इट सीम्स एंटी क्लॉकवाइज. सो लेट्स ट्राई टू फाइंड आउट द डायरेक्शन ऑफ फोर्स. वी विल स्टार्ट विद दिस साइड. ओके, सो यू कैन ऑब्जर्व दैट माय फर्स्ट फिंगर शुड बी in that direction, correct. Then मुझे second finger outward show करना पड़ेगा क्योंकि B outward है. मेरा second finger I'll be showing like this. I hope you understand. If you can see properly, my first finger is in this direction and my second finger is coming towards you. So मेरा thumb देखो, thumb is coming downward. So here the force acting is in downward direction. Let's move on to here. Let's move it fast. This is the direction of current in upward. Okay, then my second finger should be coming outward like this. Okay, so this is the perfect way. ये ऊपर जा रहा है and ये बाहर की तरफ आ रहा है. So this is the direction of thumb. मतलब इधर force act करेगा right side. Let's move on to this part. Finger this way. Second finger should be again outward. ये तो बाहर की तरफ ही आना है हमेशा. Okay, and you can see the direction of the thumb which is going up. So either force upward रहेगा. Last case, finger down, my second finger coming out. I hope you can see it is coming out and the direction of force is this side. So force direction is over here. So I have taken numerous cases to understand the topic of how to find the direction of force. I hope it is clear. I can understand bending of your hand would be difficult in all these cases, but this is how we are supposed to do it. Okay,